Next sample problem actually takes up the entire page here. When astronauts, and this is a similar question I've given in the past, but now we're actually going to look at it, make a couple of adjustments to the question. So, when astronauts travel in a space shuttle, carbon dioxide must be removed from the air they breathe. One method is to bubble the air in the shuttle through a solution of lithium hydroxide. The lithium hydroxide converts any carbon dioxide into lithium carbonate. So here's our formula. Okay, 2 molecules of or 2 moles of lithium hydroxide combines with carbon dioxide. 1 mole of carbon dioxide produces 1 mole of lithium carbonate and 1 mole of water. So air containing 25.0 liters of carbon dioxide is passed through 1.5 moles per liter of lithium hydroxide solution over a 20-minute period. The atmospheric pressure in the shuttle is 0.85 atmospheres and the temperature is 28.3 degrees Celsius. What mass of lithium carbonate is produced? Now, thing to keep in mind, although the air is bubbled through an aqueous solution, you do not need to consider the pressure of the water vapor. This is because you are dealing with the reactant and not the product. Right? We are not bubbling it through a solution of water. Okay? The water is the final product. So we are not going to need to find the actual pressure that's exerted by water at that temperature. Okay? So we have what the equation is. So let's isolate our givens. So here are our givens. We've got 25.0 liters, 28.3 degrees Celsius, which is equivalent to actually not 101.3 degrees Celsius, but actually 101.3 Kelvin. Gotta fix that. The atmospheres, the pressure is 0.85 atmospheres, and our R unit is 8.314 kilopascals of liters over moles per Kelvin. So let me just write out the actual equation here. So we've got 2 lithium hydroxide plus 1 mole of CO2 produces lithium carbonate plus water in liquid form. So from this information that we've got, right, we are asked to find the mass of lithium carbonate. So we're trying to find that. Okay. So that's the bit of information that we're being asked to find. So now, with the units that we're given, okay, we've got the following bit of information. So we've got pressure, we've got volume, we've got R, and temperature. So looking at that, we can almost figure out we need to find our N value. So we've got PV equals nRT. So we're trying to find the actual moles of the lithium carbonate. So isolate for N. N is equal to PV over RT. So actually, let's put it there. Let's put it underneath. So to find our N, let's make a couple of changes. Right? One thing, with one of the previous lessons, we decided to change the R value. What I'm going to do this time is I'm actually going to change, just to show you guys there's really no big difference. We're going to change the atmospheres into kilopascals. So we're going to multiply it by, well, 101.3 kilopascals, because 101.3 kilopascals is equivalent to 1 atmosphere. So atmospheres will cancel out. So 0.85 times 101.3 kilopascals will give me a pressure of 86.105 kilopascals. Okay. So let's use now that new number. All right, so we've got 86.105 kilopascals multiplied by our volume, which is 25.0 liters, divided by our R value, which is 8.314 kilopascals, liters, moles, Kelvin, multiplied by my temperature, which is 301.3 Kelvin. So notice here, Kelvin cancel out here, liters, kilopascals, and I'm left with moles. So the number of moles that I've calculated is 0.8593 moles. So now, this is the actual number of moles of the carbon dioxide, but because it's a 1-to-1 ratio, we know that this is good for both carbon dioxide and the lithium carbonate. So we're going to take this, the number of moles here, right? And we want to find the mass. So that's what we're trying to find, the mass. And we know that the mass is equal to the number of moles multiplied by the molar mass. And so the molar mass that we're trying to find is of lithium carbonate. So the number of moles that we have, 0.8593 moles. We're going to multiply it by the molar mass of lithium carbonate. And the number of moles, the molar mass of lithium carbonate is 73.89 grams per mole. So moles cancel out. When I multiply those two numbers together, I get 63.49 grams. The least number of significant digits in my question is 3. So I want the 63.4, but I look at that number right after it. Actually, no, I want, what are the least numbers? No, 2. I want 2 significant digits, so let me use a different color. So I want these 2. I look at the 4, right, and that 4 doesn't change anything. So the mass of the lithium carbonate is 63 grams. Okay? So the mass of the lithium carbonate that's produced is 63 grams.